right, good morning. I can do the same thing that they sometimes do in the airlines. If you do not want to go to Chicago, you have to leave now. This is the vocabulary workshop, good morning, and tutorial. My name is Reich, and I'm going to give you the intro, but all the substance are going to come from my dear colleagues, Tanya, Oleg, Vlad, Anna, Dima, and Patrick will also help. And we have a big program, and you're going to be actually working yourself as well, because we have like 3 blocks, and the blocks consists of a demo and of an exercise, which you will have to do. And we're going to go through conditions, drugs, and then measurements. It's actually getting harder from beginning of the workshop to the end. Louder. No, you have to tell this gentleman in green. Okay, then forget this guy. And I'm going to use this one. Is that better? No. Okay, louder. Can you hear me? I will remember, Patrick. All right, we're going to talk about some diseases, their treatments, and their management. I'm going to give you, like a whole medical class of what these diseases are. No, I'm not. Just going to be a quick overview. This is about rheumatoid arthritis. It's an arthritis, which means it's an inflammation of the joints, and it's painful. About 1% of the population have it, and they wake up with these swollen, painful joints, and after a while, if it keeps going, they get what's called an ulnar deviation, which means the fingers start bending into the side, to the outside, and this needs to be treated, otherwise these people are miserable. You don't see those hands anymore very often because people today are treated well, but that's what it used to look like. And then there's psoriasis, and it's also an autoimmune condition. Both conditions are autoimmune conditions. The immune system attacks its own cells and the body. It's a different autoimmune condition, so there are different antibodies. It's about 3% of the population. All of you have seen those patients already. You can see the pictures here. Usually don't look that intense. They're not all over the skin. They're in typical places, like the elbow, under the scalp, and so on. And they have this red skin, thick skin with scales, and it itches. And there's also a bunch of treatments that you can do. And there's conventional treatment with creams and UV light. And then there are targeted treatment, more modern ones, modulating the immune system. And then there's psoriatic arthritis, which means it's kind of like both of it a little bit. So it's a psoriasis with an arthritis, infection of the joints. They can very much look like rheumatoid arthritis, but it actually is a different disease. And typically, there are also different joints that are affected. It's more like the hands and the distal parts of the fingers. And it's more often asymmetrical, which means rheumatoid arthritis is always both sides, the same joint. And the psoriatic arthritis isn't necessarily so. So it's a portion, 15% or so of the psoriasis patients have this. So that's just an overview of what we're talking about, what these diseases are. But you read this article. Who has not read the article? There are people. You didn't send them out? I'm sorry, I thought the article. Interesting, why there are only 5 people said they didn't read the article. The other people guessed the right article to read. So what these people did is they did epidemiology and treatment of patients. So it's a characterization study. They took patients with these 3 diseases and they said, who are they? And how are they treated? And how are they, what's their disease career, if you want? And so we're going to play with the same entities that they did. So we're also going to look at the diseases and the drugs and the lab tests, the measurements. And so what does it mean? What do we do? So this is what their little result chapter is in the abstract. Okay, the prevalence of RA, PSA, plus psoriasis, and PSO, no, PSO is psoriasis, PSA is psoriatic arthritis. In Germany, were consistent over study period, and so on and so on and so on. So what are the things that they actually studied, or that they reported they studied? The diseases, and then women in childbearing age, and then depressive episodes, apparently that's what they had, comorbidities, systemic treatment, methotrexate, biologic therapies. These are all 3 treatments. These are the entities that were studied, or where they found significant results that they wanted to report. The problem is this: these things actually aren't like that in the data. So here they are. Oops, changed a little bit the formatting. You can't go to the data and say, give me all the records where the condition is RA. You can't say, give me all the persons that are women of childbearing age. There is no such a thing as women in childbearing age in the data. There is no such a thing as systemic treatment. Okay, so what do? This is what we do. We build cohorts of phenotypes in order to capture these concepts. And this is what it's all about. The data contains one thing, we want another thing, and we have to create the link. And we have to know that we have to make sure that this works, this is right. And it's not that simple. That's why you're all here. Let's start with psoriasis. There is, you all know, conditions are in SNOMED in the OMOP system. So there's a SNOMED concept of psoriasis. So we just take all the patients with that concept. Problem is, there are a whole lot of other concepts that are also psoriasis, also in SNOMED. They're more granular, they have more detail. Eczematized psoriasis, for example. Follicular psoriasis. All these also are psoriasis. Now what? So I can't just say, give me patients with that code. Do I have to take all of them? Next problem is, many data as they come, and people's familiarity is high, is not SNOMED, but ICD-10. There is an ICD-10 code, L40, psoriasis. Can I use that one? Well, similarly, there are more of them that are descendants or children of this particular concept. Is this, acrodermatitis continua? Psoriasis unspecified is not really with the typical ICD-10 thing. Psoriasis vulgaris, and so on. So are these other parts of psoriasis, should I take all of them? All of them? Or only some of them? This is what we're going to do today. Actually, are these the same as these? Well, obviously not, because there are many more here. But maybe these are slightly larger, but they're all in here? Well, actually, if you do this and you look, each of them actually have their own little relationship to SNOMED, except this one, which is psoriatic arthritis or arthropathic psoriasis. Same thing, just the terms converted. So looks like, even though this one, in my little introduction, is part of psoriasis, ICD-10 believes it's a psoriasis, SNOMED does not. So this is just to set the problem space, to scare you a little of what you're up against, okay? There are these entities that you want to study. They're not like that in the data. There is coding. Coding has complexity, and you have to learn, and that's what's going to happen now, how to get through this how to get to the right selections of these concepts to build those phenotypes. And you need to understand this. With that, I'm going to pass on to Tanya, and she's going to go actually start solving the problem instead of me pointing out how bad it is.
Okay, thank you, Christian. Good morning, everyone. So let us start from the beginning with making condition concept sets for psoriasis. And I would offer we revise just a bit. You probably already know that, but in an article that we are starting with, they have their data encoded in ICD-10, which is a very, very popular vocabulary. But you may know or may not know that in your data, other vocabularies are present, such as ICD-10, GM that is used in Germany, CAM-10 that is used in France, READ from the UK, and so on and so forth. You may want to capture the data that is encoded in other vocabularies, and the way that OHDSI offers you to do that with is to use standard concepts that, as Christian said, are mostly in SNOMED for the condition domain. So we have prepared this algorithm to make condition concept sets, and let's go through it a bit. So if you have source codes in your data, you would first want to probably import them, and then in order to access data encoded in all other vocabularies, you would probably want to find proper standard counterparts of those vocabularies, and we're going to do that. Then you have to check what source concepts are actually retrieved by you adding standard concepts to your set. Maybe you will need to remove some concepts or add some more concepts to your set. Then the good practice would be to examine what Atlas has in its recommended tab over Phoebe, which is probably the same, actually the same recommend. Maybe there are some other concepts that you want to add or remove. And you can iterate on that process for quite some time until you're actually satisfied with the concept set that you have. And then you have your condition concept set ready. Okay, so here is a citation from the article that Christian mentioned. And you can see that authors used 3 ICD-10 codes to define psoriasis. And you can see the codes and their respective names here in the table. And now I'm going to be switching to Atlas and doing the actual demo. And I'm going to switch to the microphone, and I hope you can hear me. Okay. That was extremely quiet. So what we need to do is we need to copy those codes, because we're going to import them. They are source codes. Okay, let me return to our slide. Okay, 1 second. Let me go to Atlas over here. So we need to create a concept set, and we're going to start with importing these 3 ICD-10 codes. Okay, so we are starting by creating a new concept set. We go to import. Since we know these are source codes, we are going to go to source code tab. And we are going to just, okay, they did not copy. 1 sec. That is weird. Okay, let's type them. L40. L40.8 and L40.9. Yeah, here we go. So let's search for those. And so here in the output, you can notice that we have several vocabularies out of the ICD family and not. And we remember that the authors use the ICD-10, so we're going to go to ICD-10. And we have the exact 3 source concepts. So let's click on all of them. Okay, Yeah, thank you. That's much better. Let's add them to our concept set. Go to our concept set and name it somehow. So for instance, it can be OHDSI EU. Psoriasis. So now, if your goal was to simply replicate the concept set that was present in the article using the ICD-10 codes, you reached your goal. However, as we talked, if you want to make sure you capture all the other vocabs that may be present in your data, you need to do that through standard concepts. So in order to do that, we need to click on the non-standard concepts. Let's use psoriasis vulgaris as an example. We go to it, and we see it's non-standard. So we can go to the related concepts tab, and here we can choose the non-standard to standard relationship, which does what it says. It looks for standard concepts, and here we see the standard SNOMED condition of psoriasis vulgaris. So we can tick it and add to our concept set, and let's check what it brings with itself. So let's check that we did the right thing. The easy and quick way to do that would be to exclude for a time the other things, and we can go to included source code tab, and let's check ICD-10. And here we have the exact L40.0 code that we wanted to capture, and it is captured by the standard concept. So let's do the same exercise for another source code. For example, let's take psoriasis unspecified. Once again, it's non-standard. We go to related concepts tab. We take non-standard to standard relationship. Here it's easy because it's only 2 rows, but it may be more. And we see psoriasis as a SNOMED condition. So let's also add it to our concept set. And let's once again check what it brings with itself. Once again, checking only the ICD-10s. And here you see a curious thing. Unlike the previous example, which brought with itself only 1 code, the psoriasis SNOMED code brought with itself not only psoriasis unspecified that we're reaching it with, but also other psoriasis that we actually wanted to capture no matter what. So now we have all of our concepts represented by standard counterparts already in the set. So you have represented your article source codes with standard concepts. And we can go to our concept set expression and just remove the non-standard codes because we know that they're already in the set since we've added the standard SNOMED concepts. So let's just remove that, save that. Okay, let's just okay. So you have made your concept set out of standard concepts. A good thing that we would advise you do after that is explore what Atlas can recommend you. So you can go to the recommend tab in Atlas. Okay, that is a problem. Okay, and I may ask you for your help. Okay. Yeah, okay. So I can tell you what would be actually there if you clicked on that. You would see lots of types of psoriasis, just as Christian showed in his part of the presentation. So if we clicked on some of them, we can see that there are actually children of psoriasis itself, of the psoriasis standard SNOMED concept, this one. So we could tick them one by one and go through all of them to add to our concept set, since we presume that we want to capture that, but there would be an easier way of doing that. And we can just choose descendants of all of those standard concepts that we have. So, as you can see, the number of included concepts and included source codes has actually risen. And if we choose, for example, ICD-10 here, you can see not only 3 ICD-10 codes that were here previously, but a huge, huge bunch of other ICD-10 types of psoriasis. And that is simply done by choosing the descendants button over here. So we have once again enlarged our concept set and made it more comprehensive. And the next step would be to iterate on what we did and go to the recommended tab once again and actually check if there is anything else that may not be captured by hierarchy, but that would be there. I hope that maybe at some point it works, but it does not. Okay. Okay, and yeah, just so that you note, not only source ICD-10s are over here, but also all other sorts of vocabularies. This is the thing that we wanted to reach, so that if you have the vocabularies other than ICD-10 in your data, you can actually capture them by looking for standard concepts. And let me just try and show you what other recommendations could the atlas give you if you went for recommend tab that would work, and it would have worked. Okay, so here is where we stopped. So we created a concept set that includes SNOMED, standard concepts, and their descendants. And here we have lots of concepts. Okay, and then you would go to recommend tab once again, and you can sort by DRC, which is descending record count, and see other codes that Atlas, for some reason, and it has its reasons, thinks that may fit your concept set. And here, if you look a bit lower, is a concept called psoriatic arthritis. And for our reasons, you may use your clinical judgment depending on what concept set you're creating. We think that it would be helpful to include it in our concept set. So if we are doing it in a demo, I would tick the psoriatic arthritis and edit your concept set. Also, you can see that here you have procedures from CPT-4 that say laser treatment for inflammatory skin disease, psoriasis, total area less than 250 square centimeters. So once again, depending on the study you're actually doing and your clinical judgment, you may want to include or not this concept into your set. We would, for this exercise and demo reason, offer to do that just to see how vocabularies work and that you can add procedures to concept sets too, and you're not limited to only conditions. So we would do that. And we would go through the recommended tab, looking at the concepts with rather high descending record counts over here, and choose the ones that we think fit. And the last thing we want to do is go to the Optimize tab. So there is this button in the concept set expression field that would try to optimize the concepts in case, for example, if some of the concepts that you've included are children of those that you also have included. It would try to remove some concepts. It would show you what it will leave in your concept set, what it will remove, and you can agree, disagree with that. If you agree, you can override your current expression, And this way, your concept set would be fully optimized to include only those codes that can represent the concepts that you need to capture the best. And so the final concept set, once again, for this exercise, as we think would be like best for representative purposes, looks like that. So it includes psoriatic arthritis, psoriasis, and procedures out of CPT. And now we're going to have an exercise. And we're going to divide into teams. And the teams will have their TAs helping them. And we're going to divide into teams based on the rows, actually. Anna, can you please help me divide? And we're going to be creating concept sets for another condition present in the article, which is rheumatoid arthritis.
So we're going to split into teams. If you guys came and thought that you will not do any work, probably this is not the right audience because we will have some fun now. We will split into teams of 5. So we will have the first 3 rows here. We can probably merge into group number 1. Then you guys have. Do we have a team who has not completed the exercise? Do we have any questions that were unsolved? Dima, can you raise your hand again? Can you? No, this person behind you. The person behind you, there is, who needs help. So at this point, what you should have is at the very minimum, the concept set with standard concepts, 3 standard concepts. And now, Patrick will show you. He will tell you what he's going to show. Yeah, we can see it. I think you can see it. If you want to make it larger.
All right. All right. All right, so we're going to, so now that you all had a chance to play around, we're going to basically walk through the exercise together. As I walk through the steps that we're hoping that you're following, please raise your hand, ask any questions you have along the way, and we'll walk through this one together. So you all started with the publication that provided 3 ICD-10 codes as the starting point. So hopefully your first step, as Tanya showed, if you are a person who finds a paper and it has some codes and you want to start there as your starting point, that's a perfectly fine entry point into the vocabulary. In the tool, you can import any list of source codes that you want. You click on the Import tab, you click on the Source Codes tab, and that's where you can paste in any list of codes that you have. As Tanya showed you, you're going to then search the vocabulary to find concepts that have that source code. The important thing here is when you are searching the vocabulary doesn't know which source vocabulary you happen to type codes in for. And so as it's searching the vocabulary, it's considering whether any vocabularies around the world contain this string of M05.8. or M06.0, so on and so forth. And hopefully I'm not going to die here too. One of the things that, well, that was unusual. Let's try that again. One of the things that I've noticed in the work that my team does is it's quite frequent that we may find a publication that has some particular vocabulary. It's very frequent that we see papers that are published in using US-based data sets that may have like ICD-9 CM codes or ICD-10 CM codes. And yet we are asked frequently to conduct some sort of analysis on some data set that contains some different vocabulary. And I don't know what's that? No, it's actually my Wi-Fi. I think I just lost that. Let me just try again here, sorry. Cacophony of, let's see here, I'll disconnect to try this again here. So it's very frequent, I'd say the majority of the time, if I'm starting a study, either wearing my J&J or Columbia hat, that somebody's inspired by some publication and they'll say like, hey, here's this paper, here's some codes, can we do something where we are able to use these codes? In the context that we're working with, what we often find is that what somebody wants to do is they want to represent a clinical idea. That doesn't necessarily mean that that clinical idea is the specific codes that are provided, though frequently it gets communicated to us as if we have to just fully replicate the code list. Part of the reason we want to go through this exercise, if my laptop's going to cooperate, is to demonstrate that if you really did, that's not so good. I may use your laptop now after that failure. You're getting the same error on. Let's see if we can try it one more time. When it rains, it pours. Oh, you know what I'm going to do? I'm going to hotspot from my laptop, my phone here. Give me 1 second. The hotspot's not hotspotty enough. All right, I think you people are worth me spending on roaming expenses. So I'm going to try that here. Oops. Back off of this. Come on. I'm going to need to use, Deem, are you able to get online? Do you have your laptop? Can you get online? On hotspot. Okay, I'm getting on my, here. It's hotspot. Mm-hmm. I'm on mine here. I'm just going to see if that'll work. Give me 1 second. I'm almost there. All right. All right, sorry for that. I'm going to try again. Hopefully enough roaming power here to do this. Let's see. There we go. Okay, there we go. Okay. All right, let's start this over. All right, sorry for that. False start, starting over. Pretend like never that happened. This is why the power of recording. We're just going to be able to cut that out, and it's going to seem like we were totally seamless. All right, so resetting. So colleague comes to me and says, hey, here's a publication. I'd like to use these codes to define rheumatoid arthritis. we can use Atlas if the goal was to just simply load in those codes. We can search the vocabulary for that set of codes. One of the things that's important is to note that you need to know the vocabulary that those source codes came from. In this particular paper, the published paper that we looked at was from a German data set that had ICD-10 codes. Therefore, we need to make sure that when we're searching the vocabulary, we are selecting ICD-10 codes. You'll notice here immediately that you'll see that there are multiple vocabularies that contain source codes with these strings, including ICD-10 and ICD-10-CM and OPCCS4 codes. I'm going to restrict myself to the ICD-10-CM, the ICD-10 codes. We can see that these are the 3 codes that Tanya had on the screen originally that are the same codes that were in the published paper. I'm going to select those source codes and add them to my concept set. At this juncture, I have a concept set that contains the source codes. And so this came up in the phenotype tutorial yesterday. Some people asked the question, can't I just use Atlas to use source codes to create concept sets and conduct analyses? And the answer is yes, you can do that. It does not enable you to be able to do international collaborative network research, so we discourage doing it. But yes, indeed, we've built the tool such that you could just create this concept set and go on your merry way conducting analysis of ICD-10 just as a point of fact. What we want to walk through, though, is the value and the benefit of using the standardized vocabularies. And we're going to go through each of these 3 codes very quickly. Seronegative rheumatoid arthritis. If we want to navigate to its corresponding standard, we can simply click on that particular non-standard source code. We can look to see what codes that seronegative rheumatoid arthritis is related to. And we can indeed see that it is related to a standard SNOMED concept of seronegative rheumatoid arthritis. Given that those are verbatim string matches, that sounds like a good match. And we can add that to our concept set. The quick trip that Tanya was trying to show you all was that if we want to now examine the implications of adding seronegative rheumatoid arthritis to our set, we can say now that we've mapped from an ICD-10 code to SNOMED, we can ask the question, are there other ICD-10 codes that are also going to map to that same SNOMED concept? And so I can go to the Included Source Codes tab to investigate what happens now that we have this particular standard. And unlike the psoriasis example, hopefully many of you saw that, when you have the standard concept for seronegative rheumatoid arthritis, what happens in the vocabulary is you end up pulling in not just the ICD-10 code for seronegative rheumatoid arthritis, but all of these fifth digit codes. You get M06.00, 01, 02, all the way through 09. And you can see all of these are more specific ICD-10 codes involving seronegative rheumatoid arthritis with specificity of the particular body part. So in this context, we would say that by standardizing, we've identified additional codes. This is where there actually is a fork in the road where you have to either decide, are you making some clinical judgment about what's right, or is your aim to specifically replicate the study? If the goal was to say, I'm just blindly replicating the study for good or bad, whether or not those codes were right or wrong, then this could potentially be classified as a problem, because we started with 3 codes and now we have 13 codes. If, however, we're thinking about this from a clinical perspective and saying our goal is to find rheumatoid arthritis as well as we can, we'd actually see that this is a tremendous value of the vocabulary, because while we were inspired by this publication that started with 3 codes, what we can see is that there are additional ICD-10 codes that all represent the clinical idea of seronegative rheumatoid arthritis that probably should all be included clinically in this definition if we're trying to represent rheumatoid arthritis as faithfully as possible, whether I'm staying in the ICD-10 vocabulary or I'm going to expand out to any other data source. Now I can repeat that same exercise for seropositive. We had the code M05.8, seropositive rheumatoid arthritis, and I can repeat that exercise of selecting the concept, navigating to its standard representation. We can see that other seropositive rheumatoid arthritis is mapped to seropositive rheumatoid arthritis. That also sounds like a logical and correct mapping that we might appreciate. And by adding that to our concept set, we can again ask the question, now that I've added seropositive rheumatoid arthritis, what has happened to my ICD-10 code list? And in the ICD-10 code list that I'll see here, now, instead of having 3 ICD-10 codes, I have 35 ICD-10 codes. Why? Because not only have I pulled in the code M05.8, which was the code specified in the original publication that we wanted to get, but now we can see we are additionally pulling in all of the 5-digit codes that have 0.8, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can also see that there was a code M05.9 and all of its descendants that are also associated seropositive rheumatoid arthritis. And so now we have a much broader set of ideas that if we are trying to come up with a clinically comprehensive set, I think it'd be reasonable to argue that if you wanted seropositive rheumatoid arthritis, you probably wanted all of the flavors of seropositive rheumatoid arthritis. The last one we're going to look at is this code that the authors had selected, which was M06.8, which is other specified rheumatoid arthritis, which of course is very difficult to understand the context of what it does it mean to either be other or specified, and one of the particular challenges of working with ICD-10 in general. If we navigate from our vocabulary to ask where does this map into our standardized vocabulary, we will notice that in SNOMED, this general idea of other specified rheumatoid arthritis maps to the concept of rheumatoid arthritis. Again, since that's the clinical idea we might be interested in, we might say that that's a reasonable thing to add. Now we have created a concept set with only standards, and I'm going to remove the non-standard so you can see it. So we've got only standard concepts, directly mapped from our original codes. But now, with just these 3 standard concepts, my ICD-10 listing here is now 70 codes. We went from 3 ICD-10 codes to 70 ICD-10 codes. And of these ICD-10 codes, many of them are going to be, I'm going to sort by record count so we can kind of look at like the big ones to the small ones. We're going to see that the top ones in the list are probably things that we would like to consider, though, for example, rheumatoid arthritis unspecified, that's a code that we didn't start with, but in fact has the largest number of records in our data set for this particular code. We can also see other clinical ideas like rheumatoid lung disease, which we would have to make a clinical determination of whether or not that's in scope or out of scope, depending on how we want to classify our rheumatoid arthritis definition. Now, the reason I want to bring this up is at this juncture, I've selected 3 concepts. We have multiple opportunities, and I got to see several of you that were playing at least with exploring the advantages of using the hierarchy in the vocabulary. For each of these concepts, we could ask whether or not, if we like the idea of clinical rheumatoid arthritis, we can ask the question or not we'd also like to include the descendants of rheumatoid arthritis. And just for the purposes of demonstrating this, I'm going to select the descendants from all 3 of these particular concepts. And now we can see that instead of just having 3 standard concepts in the vocabulary, if we say take those ideas plus all of their more granular descendants, we end up with 131 concepts. And that's a much broader array of clinical ideas that are represented here. If I look at our included concepts to look at what are those 131 ideas, we can see that the majority of the data rests with rheumatoid arthritis and seropositive arthritis and seronegative rheumatoid arthritis, which were those same clinical ideas we started with. But we can also see that a lot of those rheumatoid arthritis codes that are specific to a body site that were not initially represented are now pulled in and may be worthwhile in our data source. It's also worthwhile to highlight that now that I've created a standardized definition for rheumatoid arthritis, that not only I can see that I now have 104 ICD-10 codes. Remember, we started with 3. We've now got 104 different ICD-10 codes to consider. But we can also consider the fact that other vocabularies such as ICD-10-CM, READ codes, MEDRA, ICD-9-CM are all also represented so that this definition could be transferable. Now, what we had some technical challenges with, what I want to illustrate, is the idea of the recommend tab. So the recommend tab is basically using a combination of the standardized vocabulary's ontology, plus lexical string matching, plus patient context data that's learned from real-world data sets to create a set of recommendations of, given you liked the concepts you put in your concept set, what other concepts might you want to also consider? And in this context, based on our set of 131 included concepts, we've been recommended an additional 162 concepts to consider. Now, the reasons for these recommendations vary. There's different types of relationships that the vocabulary offers us. For example, we can consider which other concepts are being recommended because the string looks kind of similar to a string that we've just selected. Or we can ask the question that given that we've selected entities in the vocabulary, what are the parents in the vocabulary that might be a broader clinical idea that we're interested in? We can also see whether or not there are any descendant concepts that have not been selected. And we can also consider whether or not there's any patient context or similarity in patients who have particular concepts. In all of this, this is still an adjudication and a clinical review that one would go through to review all of this information. One of the things that I tend to do as I am looking through the recommendations is I like to look to see if I sort by record count to try to understand which concepts were not included that might have a large number of records in my data network that I may be interested in considering. And so I can navigate through this list to make determinations, like if I'm working with my immunology colleagues, I might ask them the question, what about rheumatic heart disease? Is that in or out of scope? I may consider asking the question about juvenile or rheumatoid arthritis and whether or not that's included. But then I also might be able to make some determinations on my own. For example, if I see something like polyneuropathy in rheumatoid arthritis. Now clearly that's a diagnosis that is about the polyneuropathy. It's not about the rheumatoid arthritis. However, there's a logical supposition here, which is to get that code, you probably have rheumatoid arthritis. And indeed, similarly, there are other types of recommendations made on similar merits where you can see additional, let's see if I can find some other examples here as I scroll down. I skip some. Let me see some juvenile rheumatoid arthritis. Oops, sorry. Here, let's do this. I'm just going to Okay, so I'm just going to type in rheumatoid just to make the list a little shorter there. So, okay, so there's an example like myopathy due to rheumatoid arthritis, for example. And so these could be clinical context that may be something that were interesting. What I'm also going to note is of the vocabularies that are recommended, you heard Christian describe that SNOMED is a vocabulary that we frequently use for conditions. But interestingly here, we also see other vocabularies recommended. For example, CPT-4 codes, which are used for procedures. We see that several procedure codes were recommended, and that could potentially be curious. However, we can see that some of these codes are actually codes used to observe status of rheumatoid arthritis disease. For example, this code here is specifically saying it's somebody with RA whose disease activity is low or moderate or high. Or we've got a code specifically that's indicating that a person is receiving a biologic therapy for their rheumatoid arthritis. So these are indicators that are indicators of a person's disease status in the in a procedure vocabulary represented in our observation domain that we could potentially be using to expand our concept list. And so simply by making clinical judgments and selecting those concepts, we can create a concept set expression that now contains both the ideas that you started with from your source codes, navigated to standards, explore the ontology to decide whether or not you want to expand or include descendants, and also use recommendations as a way to even further expand those sets. And this process, while we've tried to be purposeful in showing you the idea of starting from a source code list that you could be inspired by, really want to press home this idea that you need to decide, are you just blindly replicating somebody else's paper, in which case your goal is just to match their codes, or are you trying to use that paper as a motivation and a starting point to navigate to find the right clinical idea? My personal experience after going through now probably hundreds of these is that if your real goal is to come up with the right and correct clinical idea, publications can be a very useful starting point, but they're almost never a complete and comprehensive list that you want to end with, but rather it's a very good place to start with to get there. I didn't see anybody raising their hand because there we go, there's a hand. Thank you, Katja.
Create
So let me repeat the question so everybody can hear it and make sure that I got it right. So what you're asking about is, we started by importing a series of ICD-10 codes. ICD-10 codes are non-standard codes. It is frequent that people may think about the ICD-10 hierarchy, but that the concept ancestry that we have in terms of our standard thing does not represent that ICD-10 narrow hierarchy. So if what you're interested in is saying, I want to find all of the ICD-10 codes that belong under a 3-digit code of MO5 or something like that, you could indeed search the vocabulary for MO5 and select all of the different codes that you wanted to, or use the vocabulary to navigate to the ICD-10 hierarchy. But that is, your comment is, that seems different than what we did in SNOMED, and indeed it is quite different. In SNOMED, what we are doing is we are navigating from a given ICD-10 code into SNOMED, and then using the hierarchy that SNOMED contains to find all of its SNOMED descendants, and then we're asking the question, which ICD-10 codes map to that collected set? And so, while you will frequently find that if you can find the parent in SNOMED, it'll probably cover all of the children in the hierarchy, that needn't necessarily be the case, because you really are, as Christian showed in his collage of the concepts, the way that the folks that built ICD-10 represent a clinical idea is different than the way that the folks that built SNOMED represent a clinical idea. And so it's important to review both. Gotcha? Yep. Sure. Yeah, so thank you, Katja. So Katja asked the question about, would this button optimize, and exactly what does this do? And actually, this is going to be a nice illustration of this. So when you are creating a concept set expression, you are basically selecting concepts and deciding whether or not you want to include descendants in this particular case. And in general, I'd say parsimony is a good thing. So if we can create a very concise concept set expression that represents a clinical idea, the fewer things we have to see and review, the better. What the optimize button does is specifically looks to see whether or not there's any logical redundancy in the concept set that you've created. And it specifically, in this case, I've clicked on the optimize button, and you can see that it found that once I said rheumatoid arthritis plus descendants, I didn't actually need to also have seropositive plus descendants and seronegative plus descendants. It's saying you can safely remove these because this is logically the same concept set. Reason being, seropositive RA and seronegative RA are children of rheumatoid arthritis. And so while we navigated from the original 3 codes to get to those 3 codes, in fact, there was a much more parsimonious way of representing this, which was just rheumatoid arthritis plus descendants. And so I can simply just overwrite that, and now you can see I'm left with RA plus descendants, plus those extra concepts that we've identified from the recommender system. And you're working on the Atlas demo version? Yeah. I'll definitely check that one out. Yes, it should be the case that when you select optimize, the concept set expression should resolve to the same included concept list. The source code list should also resolve to the same thing. So I'll look at the Atlas demo to understand how we had a rogue code there somewhere. Yes, Lita. That's a great question. So the question was, noticed in the vocabulary that there was a code for history of rheumatoid arthritis. And so this would more broadly get into the notion of phenotyping and whether or not we wanted to identify prevalent cases of the disease or incident cases of the disease. In this particular case, if I was interested in identifying people who are newly diagnosed with rheumatoid arthritis, I may purposely not include the code for history of rheumatoid arthritis in my concept set. If, however, I was looking for anybody with pre-existing indication of a disease and was okay with a prevalent cohort, then I may include it. So that really comes to the clinical context of the question you're exploring. Yeah, in the specific history of source code, the mapping for the history of code actually goes to an observation of history of with a value as concept of rheumatoid arthritis. Yes.
Yeah, when we started with the ICD-10 codes, there was a step where we searched for related codes. My question is, what is a relationship between codes?
That's a great question. We're going to get through some of the relationships actually as we go through drugs with Oleg, but to explain briefly with conditions, we map the individual source codes, in this case an ICD-10 code, directly into SNOMED. So the specific mapping there is we are mapping the source code into the standard. Each vocabulary has its own set of relationships. Some of them are hierarchical relationships that we use to build our ancestry, and some are just axes for which you can learn other information about. In the, I guess I'll just search for one to illustrate it quickly. If I go back to one of our codes here, rheumatoid arthritis unspecified. So the related concepts, what Atlas is doing is allowing you to explore all of the information from starting from one particular concept, in this case a non-standard source code concept, to be able to explore the various relationships. This is, for example, to the earlier comment, this is where you can see the relationships within ICD-10. So we can see the subsumes type of relationship and the ISA type of relationship that allow you to navigate up and down the ICD-10 hierarchy. But then we have a non-standard to standard mapping, which this is what's allowing us to navigate into our standardized vocabulary, which in this context is SNOMED. And so what the Atlas tool is just allowing you to do is explore all of the relationships in the concept relationship table, as well as the concept ancestor table for those hierarchical relationships.
Yeah, I think so. I guess it's to understand the details, you have to spend a couple of things to do that part.
Yeah, go ahead, Anna.
So I think the most important thing that a basic user needs to know is that there are maps to relationships. They go from non-standard concepts to standard concepts. In this case, standard concept is SNOMED. So you want to follow this relationship to get your standard concepts, because standard concepts are used in all of the tooling, in all of the studies, everywhere. If you collaborate with somebody, they're going to use standard codes. So maps to, or in this case, non-standard to standard map, is really the most important relationship that you need to know. But then there are others. In this tutorial, we're going to show you other relationships. Oleg will talk about hierarchy, and he will talk about how to use hierarchy. Hierarchy is a relationships, and we will tell you what you absolutely need to know about that. Then Vlad will talk about lab tests and how you can use lawing relationships, and there you will learn about those specific relationships. So there are I think 200 types of relationships. You don't need to know all of them. There are basically 5 relationships that it would be nice if you know, and maps to is absolutely the one that you have to know, because it points you from non-standard to standard.
I guess what I'm wondering that when you have these two hierarchical coding systems, so I suppose that the mapping is on just some specified level between these hierarchies.
Of course, sure.
And that's what you will get when you use this.
Yeah. Absolutely. But these two hierarchies, ICD hierarchy and SNOMED hierarchy, they live separately. And for SNOMED hierarchy, you can navigate it through the concept ancestor. We have a specific table for it where you can just go up and down the hierarchy. For ICD-10, it's not in that table. So you can still explore the relationships, but you cannot go up and down. And then ICD-10 and SNOMED are connected at a certain levels. But we really don't talk much about ICD-10 hierarchy because it's non-standard.
Because other is filled in by the coder, not by the clinician.
Well, it's a, it's a, other, so ICD-10 has those things like other and unspecified and otherwise specified. Yeah, other, exactly. So this is a wonderful point. So how it's meant to be in ICD-10 is that you have, say, rheumatoid arthritis of shoulder, and then second code, rheumatoid arthritis of leg, and then other rheumatoid arthritis, which means not A and not B. Now, so you could have, if you knew that, you could have think, oh, so it's not leg, it's not arm, it's my head or whatever. Not head, but any other part. But the problem is that clinicians, and we actually tested it, we know that clinicians in different institutions use those codes differently. So you may think, oh, I use this code, other array, for this patient, but other clinicians may use it for other types of patients. So this is why it's so, like the ICD-10 coding, if you just use it as it is, it's really unreliable because you think that other people use it in the same way, which we know is not true. So that's why we offer this process where you can judge not based on how some people in some other countries use those codes, but based on some sort of objective criteria. How often those codes are used in the data, what they look like, and then we have other tools later down the road. But yes, exactly. That sort of highlights why we don't want to rely on ICD-10 solely when we create phenotypes.
And what the vocabulary team has done a great job with is by curating these mappings between the ICD-10 source codes and the SNOMED standard, we ensure that those mappings are directional, meaning that we will ensure that the source code, if it has a place to map where there's a corresponding standard concept, we map straight to that. But in the cases where, for example, it's other and it's unclear, then the only thing that's rational to do is to map it to rheumatoid arthritis. You know it's a rheumatoid arthritis of some sort, but you don't know what specific rheumatoid arthritis it is. Yep, we did, yeah, we did, no, we need to finish it.
We have to finish this. As I said at the beginning, we have what we have in the data, and we have to match it to what we want. Okay, and the other comes from ICD-10 being a statistical classification. So you always have to have a total of 100%. So you have 6 different rheumatoid arthritises, and everything else is other, which is not the 6. Should be rheumatoid arthritis, but not the 6. Okay. Do they always pick the right one and not the other, and don't just throw it into the other because who cares? That's a different question. But generally, that's the idea. There is another tutorial, how you do phenotypes, where you deal with the fact that not all codes are fully reliable, or some of them are more reliable than the other, and what you do in order to make a much sharper and better defined definition. Then, yeah, it's part of the problem.
All right. Yeah, let's take one more question. Was there a question? So what you said is if you add. Right. Of course, yeah, but that's the separate the conversation about other things is a totally different not totally different conversation, but a different conversation. All right, so now we have a choice of going on with drugs, or I saw it. But now we have an option to go on with the drugs or take a 10-minute break, but you have to be there have to be here in 10 minutes, otherwise you're gonna miss the first part. So, please raise your hand who would like to take a break now? Wonderful. We're taking 10-minute break. We're gonna address the questions that people have in between, but please be back at 11. What is in 10 minutes? 11:50. I know people want to break, but they Да, пойдем.
Glasses I already forgot. This is the spare glove.
Okay, so hello, hello. Hello, is this work? Yeah, this is working. Okay, let's move to drug concept sets. Now let's talk about drugs, and let's hope that Greek gods will be with us and they don't need another sacrifice. So, what is a drug in Odyssey? The drug in Odyssey is a combination of different attributes. It's one of them, which is really essential. This is an ingredient. And every other attributes, they just add some extra information to the drug. So, for example, in this classic example of Odyssey, we're looking into the Nicorette spray. And the basic ingredient, the essential attribute is a nicotine, and everything else is just adding information. So, for example, ingredient plus drug strength, it's a clinical drug component. Ingredient plus dose form, drug strength, and let's say brand name, it's a branded drug, and so on and so forth. So there's a pyramid of drugs in Odyssey. And now let's see how they are connected and how they connect to each other. And this is a hierarchy of Eric's norm and Eric's norm extension. It all starts with the ingredient, the top level of the hierarchy, and the ingredient here is a methotrexate, the drug very often used to treat psoriatic arthritis. And from the ingredient, you can go in two directions. So the first branch and the left side, it's a clinical drug component. And here you can see it's methotrexate, 7.5 milligrams. And on the right side, there is another branch of clinical drug forms and methotrexate oral tablet. And in between of ingredient and clinical drug forms, it's an intermediate layer of clinical dose groups. They are very helpful aggregators. So it's methotrexate oral products, and everything that's related to oral product will be there, pills, tablets, granules, and everything else. So these two branches, they merge into clinical drug. So clinical drugs basically inherit the attributes of clinical drug component and clinical drug form. Now it is methotrexate, 7.5 milligrams oral tablet. And if you add brand to clinical drugs, you will get branded drugs. So methotrexate 7.5 milligram oral tablet with some brand, and this is a step in the hierarchy when you can really easy recognize the drugs. Brand names is what you tell pharmacist. We can also add brand names to clinical drug components, and then we'll get branded drug components. If we add brand to clinical drug form, we'll get branded drug form. And there are also some other classes like quantified branded drugs, marketed products, they are less relevant in this example, and they're mostly used for liquid drugs. And the most important part of this slide, it's actually the idea that everything is connected, and that's everything is connected to the ingredient, which is the top level of the hierarchy. And now let's zoom out a little bit and remember that drugs can be classified. So we'll speak about HDSI, which is a classification of vocabulary for drugs. The bottom level of HDSI is an HDSI level 5. It's a group of drug products. And the bottom level contains ingredient plus route of administration. So in our case, it's a methotrexate. It belongs to HDSI group of methotrexate, systemic, immunosuppressants. And this HDSI code is connected to ingredient and clinical drug component, and very important here, clinical drug forms, the one relationship in orange. And as I said, HDSI is a classification, so there are different HDSI codes. They seem kind of redundant because methotrexate, systemic, immunosuppressant, then immunosuppressants again, then twice immunosuppressants. And it belongs to antineoplastic and immunomodulating agents. That's how HDSI works. And now I'll go through 5 scenarios. Scenario 1 is ingredient. So we start with finding methotrexate, and then we'll go all the way through to systemic corticosteroids. I will switch to Atlas. I hope this is working. Yeah, great. So we switch to Atlas. And start with, yep, sure.
So, probably a stupid question, but can a clinical drug include any number of ingredients?
Yeah. Yes, we'll go through. Yeah, so the question is if clinical drugs can contain different ingredients, and yes, they can, and we'll go through the different ingredients, how to find the combo drugs. We'll go through it. Yeah, we'll go through it. Yeah, we'll go through this in our scenarios. So the basic scenario, the first use case to find methotrexate. We go to, again, we can start from concept set. We can start directly from the search, and we just type methotrexate here. Click on the search, and it's not helpful. And here, in a second, you will see lots of drugs. All of them are connected to methotrexate. Yep, and we can filter by vocabulary. So we know that this is an Eric's norm, and we can filter by concept class. So we know this is an ingredient. So we click on ingredient. There is only one ingredient that actually we were looking for. If we remove filter of Eric's norm, we will see the methotrexate in different vocabularies, like DN plus D, DPD, BDPM, and everything. They are all mapped and connected to the Eric's norm ingredient methotrexate. So just click here, go to the bottom of the page, click on this sentence, and we add them to the concept set. Go to the concept set, and now in our included concepts, we will see lots of drugs with the different forms, different formulations. They will all be connected to the methotrexate. That's scenario number 1. So what to do? Just choose an ingredient and the sentence. Scenario number 2 is an ingredient with a certain route of administration. Let's say we want only the patients treated with oral methotrexate. So what to do in this case? Again, we start with an ingredient and all of the sentence, and then in included concepts, we select appropriate either clinical dose groups or drug forms and the sentence, and then we should not forget to remove the ingredient from the original definition. So go back to Atlas. So we already selected the ingredient from our previous example. Metatrexate is here. We go to included concepts tab, and then we filter by concept class. We are looking for clinical drug form, and you see that there are 10 potential clinical drug forms. We only wanted oral, so we can select oral capsule, oral solution, oral suspension, oral tablet. We click on the descendants, the bottom of the page, then we add them to our concept set. But at this moment, the number doesn't change because there is like we only picked some of the concepts from the list of included concepts. Then we remove our original definition, methotrexate, and we see that now there is only 532 drugs, and all of them are some oral forms, different oral forms. You can click and sort them by standard record count or record count and see what's used more often or less often. So that's if you want to ingredient, once again, if you want an ingredient with a certain route of administration, you should start with ingredient, then pick the descendants, and within this descendant list, just select appropriate clinical dose groups or drug forms. So the third scenario is combo drug. No, the patients with psoriatic arthritis, because of the treatment, they very often develop some complications, infectious complications, and they are treated with antibiotics. One of them is a combination of trimethoprim and sulfamidexazole. It is a combo drug, so if you just select an ingredient, we will not necessarily get a combo drug, right? So, but what to do in this case? In this case, we use one of the ingredients, we click on it, select all of the descendants, and within these descendants, we go to the clinical drug forms and we search for this specific combos. So let's try it. Go to my original concept set expression. I remove concepts, so it's clean. Go to search. I'm looking for one of the ingredients. And as in our original scenario, we'll see list of drugs, not necessarily ingredients, but drugs with this ingredient. Should be lots of them, but we only need one. We only need a basic ingredient to start with. Well, maybe we need to do another sacrifice. But okay, I'll jump to the slide to show you the idea what we're supposed to use these relationships from ingredient to clinical drug forms, and then go from clinical drug forms below. Once again. Yeah. Maybe I have slides. Go through slides. Just give me a moment, please. So we are going to another very helpful resource. A very helpful resource where you can browse all the vocabularies. So basically type everything here. It does not have functionality of concept class or something else, but it does have filters here, and you can browse all the relationships between vocabularies. So if you click on the left side, if you click on the standard, you click on the vocabulary you select the Eric's norm. There is one trimethoprim we are looking for, so this one. And if I just copy the concept ID of this ingredient, let's just maybe work this way. And I'm now looking for concept ID. Okay, it's two ways. So we can go through this and import the concept ID from the search results. We can go to the concept set, and we can go to the import tab. That's what we were doing in the original definition. So it's doing the first part. We click on the sentence. We add to the concept set, and we see that this is here. Trimethoprim with the sentence is here. Now we go to included concepts, and there we'll be looking for clinical drug forms with a combo drug. There's kind of 2,500 concepts. Okay. I have slides.
So while we're still searching for the included concepts, the reason I think can you let's see if we can actually look through them. I think we realized that we missed an intro step is why we even talk about this hierarchy. So for drugs, we really have a very nice Rx norm structure. And it's really nice because it's nicely organized. There are clear rules that we just showed you, that Oleg talked about. Things are connected within one nice hierarchy. It follows the logical rules. You can actually look at it and you can understand it. So that's why the process that we're following here is very much a straightforward process. You saw we took ingredients plus all descendants. We took clinical drug form plus all descendants. And we're going to be using descendants all the time because for drugs specifically, we believe that the hierarchy is really nice and we can confidently use it to get all of the kits, as opposed to some questionable aspects of other rheumatoid arthritis. So here you would see that in all of the exercises, we're going to use those descendants. And we have Rx norm for US market, in US drugs that are in the US market. And then we have Rx norm extension as an extension for international markets, where we collect drugs from different countries like Australia, Germany, France, but both of these vocabularies follow this very same structure. So that's why we can utilize it in this very nice manner.
Yeah, thank you, Anna. So the first question from the audience was about clinical drugs. So whether clinical drugs can have 2 or more ingredients. No, we're at the moment looking for a combo drug. If we filter by clinical drugs, we will see lots of them with multiple ingredients. But it's not the right way to find the combo drug. So the right way would be to filter by clinical drug forms. It would be 46 of them. So multiple options here. Can filter, prioritize your review by record count, descendant record count, or you can walk through all of them. You can just filter here by the second ingredient. That would be, yep. And okay, so it's timeout. It's not working here. So if we type sulfametoxazole, then we only filter to a couple of clinical drug forms, and some of them are clear. So it's only 2 ingredients, like this one, example for oral solution, for oral granules, oral capsules, IV, and everything. Everything's available here. And you'll also see that there are different drugs with combinations of codeine and chlorpheniramine and other drugs. So now it's the question actually to you. So, it's your decision making whether you want to include them or not. So if you want only a clear combination of sulfametoxazole and trimethoprim, you should select these concepts. If you if you agree that the patient could be treated with other combinations, then you may also want to include these drugs. But once again, the right way to do it is a clinical drug form. I jump to the presentation and yep. Yes, of course. That was Anna was talking.
Repeat the question.
Yeah. Thank you. So the question was why is there OMOP here in the concept code field? As Anna told us, that there are two main vocabularies for drugs. One is Eric's norm and one is Eric's norm extension. And Eric's norm vocabulary is covering the US market, and Eric's norm extension has been created in OHDSI, and it's created basically it's following the same structure of Eric's norm. They are all included in one hierarchy, but it is created in OMOP. So that's why concept code is OMOP. And you see that all of them with OMOP codes belong to Eric's norm extension vocabulary. And this one is numbers here. It is an Eric's norm, numbers, Eric's norm extension, OMOP plus numbers. So that's the structure of Eric's norm extension. So let's go to scenario number 4. It's actually a little bit more difficult. It's where we really need just one place. That's where we really need hierarchy and classifications. So let's say we want to find patients treated with tumor necrosis factor inhibitors, so-called shortly TNF-alpha inhibitors. Again, they are used to treat psoriatic arthritis. You can just copy the definition, go to the search tab, and look for ATC, because this is a classification of drugs. We see that there is only one concept in ATC. It's ATC class number 4, so it's not the most granular. We click on it. See there are lots of descendant record counts. Go to the bottom of the page. We click on descendants and we add to concept set. We go back, remove the original ingredient. Again, go to the included concepts. And here, we want to get back to ingredients. And then that's the way to check if all the concepts are there. And that's the way to limit your concept set to ingredients of TNF-alpha inhibitors. So if you need a class of drugs, then you need to go from ATC and to ingredients, to forms, and further. You have a question?
Yeah, it's related to this table here. So there's some statistics in this table. Where can I find the descriptions of these statistics?
So the description of the numbers, the one question is whether there is a documentation for these columns from Atlas, which Patrick may have a good, maybe book of Odyssey or something. But in the nutshell, for now, we have the following numbers. We have RC, this is record count. DRC, this is descendant record count. So record count is how many occurrences in a given data this code has. Descendant record count uses hierarchy, and it tells you how many records in the data you observe for this code plus all of its kids in the hierarchy. Then PC is a patient count, DPC is a descendant patient count. So that will give you numbers for patients, how many patients there are with this code or with this code plus descendants. In these numbers specifically, if you see on your right side, you see view record count 4. Right now it points at Atlas Prod. So where these numbers are coming from is the network study we did 5 years ago, where we took the information about 22 data sources in the Odyssey network. We combined that information together, and these counts represent the counts of these records in those 22 data sources. So that gives you information about some piece of network, of Odyssey network. And of course, if you have Atlas at your instance, in your institution, you will see the counts for your own data. But on the public Atlas, you have synthetic data, and you have counts from the network.
And that's a nice way to prioritize your review if you have lots of concepts to check. So we went from the ATC, we included ATC in our concept set expression. Now we click on included concepts, and we filter by ingredient. And we see that there are 5 ingredients under this ATC. We click here, so we include all of them to our concept set definition. We click on descendants, we add them to concept set. Then we go back, and we don't have to use ATC anymore. So we click, we remove ATC. Now we have beautifully all of the ingredients related to this concept class. So the next case is a class of drugs with a certain route of administration. Like, very often patients with psoriatic arthritis are treated with systemic corticosteroids. What to do here? Again, it's a classification. It's a drug group. So we need to start with ATC. We take ATC, add some certain codes with descendants, and then we remove ingredients from this definition to use this link in our definition. So I jump back. I will remove all of the selected codes in here. And we are looking for corticosteroids. As a little bit of a spoiler, we know that there would be multiple ATC codes, and I will show you how to select the right one and what can be wrong with the ATC. Okay, so we see that there is this one, ATC second code. It's kind of almost the highest level. If we click on this code, of course, it actually represents everything we wanted. Is corticosteroids for systemic use. We click on the hierarchy. I see that this concept has one parent. It's actually not relevant in our case. It's very high level ATC first code. Then this current concept, corticosteroids for systemic use. And if we check children of this code, if we, you can hear me, sorry. If we check children of this code, we see that there are corticosteroids for systemic use plain, so no combinations, only corticosteroids. Then corticosteroids for systemic use in combinations, very often with antibiotics. And then, for some reason, it's anti-adrenal preparations. And inside this anti-adrenal preparations, there is a ketoconazole drug which we don't want to include in this definition. So it's chemically it's a steroid, but not one to use for the condition like psoriatic arthritis. So we include these two concept codes with descendants. We add them to concept set. We go back to our concept set. See that they are included. Then we jump to the included concepts, and there will be lots of them. What we need to do, we need to pick ingredient from the list of concept classes, then exclude these ingredients because we only want this. We want relationships from ATC to clinical drug forms. And if we just select all of the ingredients, because of the hierarchy, we will select all of the related concepts, all of the concepts with this ingredient, not necessarily systemic forms. So it's 17,000 concepts, and not always works properly. But once again, what we should do, we should select ingredients. We should remove them from our concept set definition, and that would be it. We will use this relationship to define systemic drugs.
So I think this is one of the points that we really want to highlight. ATC is used a lot in Europe. So you may see people coming to you saying, I have an list of ATC codes. Can you help me do the study? So that sort of refers back to the question, if you take ATC code and you take Rx norm ingredient, do you get the same drugs? Well, the answer is no, because ATC fifth level is not an ingredient. It is ingredient plus route of administration. And the name will not tell you that. For ATC names here, we added, we in fact added routes so that people know what kind of fruits they are getting. But it's always route of administration plus ingredient. So what it really is, as you saw, it's not an ingredient, it's a clinical drug form. So ingredient plus drug form. And this is what you should be getting. So whenever somebody comes to you with an ATC list, you should ask them, do you want these ingredients, these drugs? Do you want all methotrexate? Or do you want systemic methotrexate if the ATC code says methotrexate systemic? Because maybe what they want is any methotrexate. They just used to have those ATC codes. So that asking this simple question will really help you. And if they tell you, I want systemic methotrexate, well, then you know that you can use our relationships to jump from ATC fifths to clinical drug forms and get your list of codes, and there the list will be the same. Or if they say, no, in fact, we want all methotrexate, then you know that you can jump from it to ingredients, take all descendants, and get your source, get your code list. So essentially, you need to know, when somebody gives you ATC list, you need to know whether they want these specific codes for some reason, or just drugs with these ingredients. And that would really help you. And of course, depending on their question, the approach will be different.
And the final use case is a kind of bonus use case.
No. Can you walk through what you did, because I was talking about other things.
Because, yeah, sure. So yeah, let's get back here. So I went to included concept step. I selected all of the ingredients. I added them to concept set definition, and I add them as excluded concepts. So this way, we have only ATC, and we exclude ingredients to use the relationships from ATC to forms, and that's how we get systemic corticosteroids. Our last case, it's a bonus use case. If you have, once again, if you have a specific set of ATC codes, so you have ATC code list from someone, and then you're actually supposed to use a recommended button, recommended tab, and there would be maybe more ATC codes with the same ingredient. We will show you during our session. So if you have this use case, please contact us, and we will tell you what to do. And
yeah, no, even before that, I think I still want to highlight this point, because we've had numerous conversations about ATC with different people, like lots of them. And can you go back to scenarios? Mm-hmm. And so far, what we saw people doing with ATC codes is these scenarios. So the one scenario is when you take a class of drugs, but you really want to know which drugs belong to this class. So this is where it's scenario number 4, where we say, take ATC class, find ingredients, Rx norm ingredients, and then just use Rx norm hierarchy, because Rx norm hierarchy is really good and robust. So that's use case number 1. Then what we also saw people do is when they say, well, I want class of drugs, but I also want a specific route of administration, because corticosteroids that you put on skin have different effect from injectables, right? So this is use case number 5. So there you can use ATC connections that we build, because we build them with thinking about route of administration. So there you would actually get just systemic corticosteroids. The only thing is that you need to exclude ingredients, as Oleg showed. And then the final list is where somebody just give you ATC list and they tell you, these are specific codes I want to use. There we would use recommend tab, so we will show it later today. But the basic idea there, that you can go from those ATC 5th level codes to Rx norm drugs. Like you can do this. You would just click the ATC, you would add ATC, you would include all descendants, and you'll get Rx norm drugs that correspond to that ATC. But then the recommended tab will suggest you other ATC codes that you may want to include. Because we oftentimes see that, in fact, when we looked at one of the Darwin's protocols, they gave a list of ATC codes, and we were able to identify other ATC codes that we thought they could also include. So this is what we implemented in that recommend tab. If we get it to work, and we will show it to you. But to summarize, and I'm blubbing for quite a while here, we do think there are different use cases with ATC if you have interest in ATC, and there are different ways to use ATC in the OHDSI vocabularies depending on your use case. So your pathway will be different. If you don't care about ATC, if you have no specific interest in that, please use Rx norm. It is a nice, clean hierarchy that you most of the times, actually not most of the times, that you can trust. And with that, we will split into, no, we will not split. We will have lunch. But after we go back from lunch at 1:30, we will have exercises with drugs. And I'm sure it was a lot of information, so we will be actually able to, get down to business and do all of the scenarios ourselves. So that's point number one. And then after drug exercises, we will go through lab tests. And that would be a demo as well. So please come back. I hope to see all of you, and I'm looking at all of you, after the lunch break. So, we're going back at 1:30. So we have 1 hour lunch break, and 1:30